Assalamualaikum everyone. So today we will discuss about the logarithmic and the exponential function. So in the first I will discuss about the exponential function. Then later we will see what is the logarithmic function. So in the exponential function, the term expo means the power. The term expo means the power. Consider a function let y is equal to b raised to x. It is a function. Okay. Where b is base. B is base of this given function and x is power. So b is always greater than 1. Where b is always greater than 1. That means base of this function or the b value is always positive terms. Okay. So these functions, this type of function is known as exponential function. Exponential function is like from the word expo, that means power. Here we are using power, base should be its power. That's why we are calling this one as exponential function. And remember that always the base of the given function is greater than 1 and hence it is always it is having positive value. By using the graph, you can easily understand this. Here we are having a function y is equal to 10 raised to the power x. We are taking a function as y is equal to 10 raised to the power x. So see this, in this graph, the domain or the x values are any real numbers. It can be positive values or it can be negative values. So in the x values, we can take all the real numbers including positive and negative values. Okay. But here in the y-axis or the range of the given function is, we know that b is always greater than 1. So we have to take b as the positive value. So the b is always greater than 1. That means the range of the given function or the y value of the given function are always positive. So always the range of the given exponential function is positive. And x values of the domain are either it may be positive or negative real number. Okay. So see here in this graph, you can see that whenever as the values of the x increases, this graph also increases. Means always the exponential, the graph for the exponential function is always increases. Why? Because as we are taking the values x here, whenever the value of x increases, then the graph of the exponential function is also increases. Okay. Now if we take the highest negative value, if you are taking highest negative value of x, x dash on x dash or the left side of here, we are having negative value of x. So whenever we are taking highest negative value for the x-axis, the graph of for the given exponential function or the y values comes close to the 0. So whenever we are taking greater value of the negative x-axis on the negative x-axis, then the y value comes close to the 0. Okay. And the domain is for all positive and negative real number and the range or the y value for the exponential function is always positive. Okay. So this is the exponential function. Here we are having types of exponential function. Two types of exponential function. One is common exponential function. Common exponential function. In this function, we can see that y is equal to b raised to power x is the exponential function. It is, we are representing exponential function mathematically in this way. Common exponential function means we are having base 10. In the common exponential function can be represented in the mathematical way by y is equal to 10 raised to power x, where 10 is the base. Base is here 10. So in always in common exponential function, base value is always 10. So this function, first type of function is known as common exponential function. And secondly, we are having natural exponential function. In natural exponential function, Consider a function y is equal to e raised to power x. Remember this, in natural exponential function we are having base as e. E is here, it is Euler's constant, and the value of e is always we have to take e is equal to 2.718. It is approximate value. It's the approximate value of e. E is here exponent. E is Euler's constant. It is known as Euler's constant. Its value is 2.718. Approximate value we are having. So this is the exponential function, and where we use the logarithmic and the exponential function. Nowadays we can see the growth of population in finding the growth of population, or how much interest we can get by an investment. Such type of complicated for calculation of such type of complicated problems, we can use the logarithmic and the exponential term. Okay. So in the graph you can see the always the graph of exponential function is increases. Why? Because as we are taking the negative values or the value of x increases, the y values also increases. That's why always exponential graph function for exponential graph is always increases. Now we can see the logarithmic function. Logarithmic function. Okay, right. Now logarithmic function means, consider let b is any real number. Let b be a real number. Then logarithm we can write as log of a to the base b is equal to x if b raised to x is equal to a. Here b is base and b is greater than 1. We can read this one as log of a to the base b. So if b is a real number, if b is any real number, then we can take log of a to the base b is equal to x if b raised to x is given to you. B raised to x is equal to a. If it is given, then we can write exponential. Here we are writing exponential function in terms of logarithmic function. How? Base is same as it is. If you are taking log, base is same as it is log of b of a is equal to x. Okay. Suppose we are having 2 raised to power 4. 2 raised to 4 is 2 into 2. 4 times we have to multiply 2. Then it is 2 to the 4, 4 to the 8, 8 to the 16. Okay. So how we can write this given function in the logarithmic form? So always remember base is as it is. Here in the exponential and the logarithm, base is as it is. So what is base? Base is here 2 log of 2, and we are having x as 4. We have to take 16 is equal to 4. We got 16 by multiply 4 times, by multiplying 2 multiplying 4 times, then we will get 16. So we have to write log of 16 to the base 2 is equal to 4. Similarly, if you are having 10 raised to the power 3 is 1000. So how we can write this in the form of log? Write down log of 10. Base is same in both logarithmic and the exponential form. Log of 10, log of base 10, log of 1000 to the base 10 is equal to 3. This power goes on the right hand side of this in logarithmic form. Whenever we are having power, this power goes on the right hand side of the logarithmic in the logarithmic equation. Log is also simple. In the log, here if we are taking log in the exponential function, if we apply log in the exponential function, then this power goes to right hand side of the logarithmic function, and base is same as it is. This a we have to take log a to the power. How we have to write this? Log of a to the power b is this one. So this is the mathematical expression or the mathematical form of the logarithmic function. Now we will go for the properties of logarithmic function. In logarithm we are having some properties. So write down the properties of logarithmic function as b is real number. In the logarithm we are taking base which is the real number. Always it will be a real number. Properties of logarithmic function. Write down properties of logarithmic function. These properties are important and we can use these properties while solving examples. So first property is changing base. First rule is change of base. First one is change of base rule. In this we are changing the base of the given logarithmic function. How you can see log of b p we are having. We can take here log as a. Log of p to the base a is we are having this. So we can write this in the form of log of p divided by this base. We have to take this base as denominator. Sorry, this one is a. This base we have to take this one as denominator on the right hand side. So here the base log of p to the base a it is given. So we are writing this in the form of log of p divided by log of a. Whenever you are having base, this base goes into denominator. Log of a. Now for base we have to take base as b. B is any real number here. Okay. This one is first property. Second property is we are having. Suppose we are having log of p q to the base b. If we are having, then we can write this one as log of p to the base b plus log of q to the base p. Okay. This is the product. Here we are having PQ in the form of product. In multiplication we are having. If we apply log these two, then it will become in the addition form. We can write log P plus log Q to the base B. Suppose we are having log of B as P dot P means I'm replacing Q by P. Then see what happened. Log of P to the base B plus log of P to the base B. Okay. This log P it will become 2 log P to the base B. And here it is log of B is P into P is P square is equal to 2 log P to the base 2. Sorry, here base B. That means in general we can write this property as it will become another property log b to the power m is equal to or m or n we can take. Suppose n is equal to n log of b log of p to the power base p. So whenever we are having this one is the third property. So if we are having power p raised to n log p raised to n, then we can write n log p to the base p. So this one is the third property. Now write if here, see here, if both p and q are in multiplication, then we have write in this as the addition. The addition of these two, if we are having these two p and q are in the multiplication form, then we can write this in the addition form. What happens if p and q it is given in the division form? P by q to the base b, log of p by q to the base b. We can write this one as log p to the base b minus log of q to the base p. This is the fourth property. So first one is change of base rule. In this property, we are changing the base of the given equation. Means we are having log of p to the base a. We can write this one as log p log a. The base, how to write it is a very simple. Base it goes into the denominator on the right hand side. Okay. Then we have to take base as in general b, where b is an element. If the p and q are in the product form, we can write this in the addition form. P plus log p plus log q to the base. Here I am replacing q by p. Then we are having by using this property log p plus log p equal to 2 log p. So p into p is p square. To log of p square to the base b is equal to 2 log p. In general, we can write I am replacing 2 by n. If log of p raised to n of b we are having, we have to take this n power n in the product form. Multiply, we have to multiply this power n into log p to the base b. Now this is the fourth property. Here we are having the second property, we are having p q in the form of product multiplication. What happens if the p and q are in the division form? Then we have to take, for division we have to take subtraction, or we are having minus sign here. For the multiplication we are having addition. So I will take some example of logarithmic and exponential function in the next class. Okay, thank you, Jazakallah.